Combining like terms. So this is going to work similarly with our distributive property, but we're going to talk about it first without the distributive property. So like terms are two terms that have the same coefficient, and we can combine them together into one. So when we combine them, we need to make sure the variables are identical to each other. You're going to end up with a bunch of variables or one variable, and then the number in front. The number in front of a variable is called the coefficient. Again, notice that there's no operation in the middle, so we're assuming that it's multiplication. So to combine like terms, we're going to add or subtract the coefficients, and we're going to keep the variable the same. Since we're adding two things that are alike, they're going to be the same thing when we're done as when we started. So I have 3x plus 4x here. Notice they both have the same variable. They're both x, and then I've just got different amounts of them to start with. So I'm going to add or subtract the variables, so 3 plus 4, and I'm going to keep the coefficients. I'm going to add the coefficients, and I'm going to keep the variable the same. These are both x's. They're going to stay in x. So 3 plus 4 gives me 7. I end up with 7x. So 3x plus 4x is 7x when I simplify it. That's all I'm doing, simplifying. I'm not solving anything. I'm just simplifying. Let's try another. 4y plus 6y minus 2y. So these all have the variable y. They're exactly the same. They're not y squared. They're not xy. It's y and just plain old y. So I can take the coefficients and put them together. So 4 plus 6 minus 2, and then tack that y on the end here. So I have 4 plus 6 is 10, minus 2 is 8, so I end up with 8y. Here's another one with two different variables going on. 11w plus 9y plus 3y minus 5w. I'm going to regroup these so that my terms that are alike are together. So 11w minus 5w plus 9y plus 3y. Now I didn't write it out the way that I wrote it out here. You don't have to write it out once you get the flow and how it works. So 11w minus 5w is 6w, and 9y plus 3y is 12y. When I show it this way, this is really kind of an undistributive property. If you look at this backwards, you'll see that I'm taking this y and I'm really multiplying it by everything inside the parentheses here. So negative 2 times y is negative 2y, 6 times y is 6y, 4 times y is 4y. So sometimes I call this the undistributive property because I'm kind of undistributing things. I'm taking the y out of everything and putting them all together, just as some background for it. You don't need to show it this way. You're welcome to simplify it and just do it this way. This is how I'll be doing it from now on. All right, let's look at a few that are a little trickier, that have a few more things going on. We're going to put together our combining like terms with our distributive property. And I'm going to use a few examples here which are kind of the tough ones that you'll see eventually as we go along. So 5, and then parentheses x plus 2x minus 4x. So again, when we think about our order of operations, I want to deal with parentheses first. So I'm going to multiply my 5 times everything in the parentheses. So 5 times x is 5x. 5 times 2x is 10x, and then I've got this negative 4x hanging out of the back here. They're all x's, so I can combine them together. 5 plus 10 is 15, minus 4 leaves me with 11x. So I may have to do a few things, just as with my order of operations. I may have a few different sets of operations going on. I just need to deal with one at a time. All right, let's deal with the two trickiest ones we'll see as far as combining like terms in our distributive property. 8 minus 2, and then in parentheses 3d plus 5. What everyone wants to do is 8 minus 2. But we can't do that because this 2, this minus 2, is actually stuck to the parentheses, and order of operations says do parentheses first. So we have to do that. It also says that this 2 in the parentheses is multiplication, and I have to do multiplication before I do subtraction. So no matter how I look at it, I can't do 8 minus 2 right off the bat, but everybody wants to do that. Don't resist the urge. It's also a minus, so I'm going to highly suggest that you change that to adding the opposite first to remind yourself that that negative sign goes with the 2. So when we distribute that 2, it has to be a negative 2 that we distribute. This 8 is just going to come along for the ride for a little bit until we have something to do with it. So negative 2 times 3d is negative 60. Negative 2 times 5 is negative 10. No parentheses left. I've just got addition, so I can put together terms that belong together. The 8 and the negative 2 are alike, so I can put those together. So I end up with negative 60 plus negative 2. Last one, I've got 7a minus, and then in parentheses 3a plus 4. Notice there doesn't seem to be anything in front of the parentheses there. There is something in front of the parentheses there. There's that invisible 1 that I've talked about before. That 1 shows up lots of places. It can show up in front of our variables, like this x really has a 1 in front of it. And these parentheses always have a 1 in front of them if there's nothing else there. So I'm really going to put that 1 there, and I'm going to change this subtracting to adding the opposite. So I really have to distribute a negative 1 over everything in my parentheses. So the negative 1 times 3a is negative 3a. The negative 1 times the 4 is the negative 4. Now I can combine these since I only have addition left. 7a plus negative 3a is 4a. This negative 4 doesn't have a like term to combine it with, so it stays on its own. I can, if I want, change this to, oh, that's not wrong. That should be a subtraction sign there. So I could change this to 4a minus 4. I don't have a marker, so you're just going to have to imagine the minus 4 in there. Okay. So be careful with your distributive property when we go along, and we make sure that whatever's in front of those parentheses, we make sure we distribute it along everything in the parentheses, and we also make sure that if we see any terms that are alike, we combine them.